Okay, everyone, let's begin then. So, functions and function transformations. We will be solving questions on functions and function transformations in today's class. Let me know the problems that you have from any of these topics. So, can everyone please write down the problems that you have from both the worksheets, functions worksheet or function transformations worksheet? I'll start with this. Let's start with functions first of all. We'll start with functions. Worksheet E1. Functions. Okay, so any remaining questions from this worksheet, first of all, let me know about them. Question number 29 and 32. All right, let's have a look at these two questions first. Questions 29 and 32. Let's start with this one. This is question number 29. Okay. So there seems to be some problem with the way it is written here, this thing and this thing. So I need to go and check the actual paper because the way this worksheet has been made, I think there was some problem while making the PDF. Has anyone checked this? What these numbers actually are? Is it 2x minus 3 whole raised to power 4 and 2x minus 3 whole squared? Is that what it is? Has anyone confirmed this? Okay, so check this paper, November 2018, paper 1, question 11. Okay, have a look at this paper and see what this question actually says. What I'll do is I'll just copy it in the meantime and we'll start working on the first part. And then please, can you guys confirm this from the actual paper? Whether it's 2x minus 3 whole raised to power 4 and 2x minus 3 whole squared and B1. Please confirm that. Let's start with this. Question number 29 from the worksheet. 29. Okay, so it says the one-to-one function f is defined by f of x equal to this for x less than a, where a is a constant. State the greatest possible value of a. Now, how do you understand this? How do you understand this? They have given that it's a one-to-one function. What is a one-to-one function? That gives you only one value for y for each value of x, and every value of x also corresponds to just one value y. So it's one-to-one both ways. How do you check that on the graph? Graphically, we can use the horizontal line test to see whether the function is one-to-one or not. This is a quadratic function. We know how the graph of this function looks like. They've given us the completed square form. First of all, is it a U-shaped graph or an N-shaped graph? It's a U-shaped graph because the number outside is positive. So it's a U-shaped graph. It's going to look like this. That's one thing. Now, this whole graph is not one-to-one because it fails the horizontal line test. If you draw a horizontal line like this here, it cuts the graph at 2 points, so it's not one-to-one. What's the turning point of this function? The turning point of this function, let's suppose that's around here. What's that? If you compare it with the completed square form, the standard form, this is going to be the value for h, which is 3. And this is the value for k, which is -1. So the turning point has coordinates 3 and -1. This is the turning point. The domain that we're given for the question is x less than a. What that means is on the x-axis, so let's suppose we've got the x-axis somewhere here. This is the x-axis. On the x-axis, we have this point as x equal to 3. There's some point a such that if you only consider the left side of that, the function would be one-to-one. Okay, there's some point A on the x-axis, such that if you consider the left side of the graph from that point, it will be a one-to-one function. Now, where could that point A be? Let's suppose that point A is here. If A is here, then to the left of A, we would have this whole function, this whole curve. Is this yellow part one-to-one? Is this yellow part one-to-one? It's not one-to-one. So A cannot be something on the right side of the turning point. That's not possible. Okay, let's take another scenario. Let's suppose A is here. If A is here, that means we are looking at the part of the graph to the left of A. That's this part of the graph. Is this one-to-one? Yes, this yellow part is one-to-one. They want us to find the greatest possible value of A. The greatest possible value of A. Now, is this A the largest possible value that we can have for A? No, because even if we go a bit more to the right, even if we go a bit more to the right, for example, earlier A was here, we can keep going on a bit further, and this is still one-to-one, and we can keep going on and keep going on until we reach the turning point. Until this point, this is still a one-to-one function. However, if you go even a little further than this, it will not remain one-to-one because it will fail the horizontal line test here. So you can only go as far as the turning point. So what could be the largest possible value of A for this to remain a one-to-one function? This value, which is 3, so you would say the greatest possible value, the largest possible value of A, that is going to be equal to 3. Now, in all such questions, now that's the logic behind it. But in all such questions, now you understand, you would just write down the x coordinate of the turning point. Because if it's a quadratic function, then to the left of the left of the turning point, you have one-to-one, or to the right of the turning point, you have a one-to-one function. But if you have turning point in the middle of, if you have turning point in the middle of the curve, then it will not be a one-to-one function anymore. Okay. So that's the largest possible value of A that we get. Any problems with this? Any questions, anyone? Thank you for checking that, Zara and Aisha and others. So for part B1, this function is actually 2x minus 3 whole raised to power 4 and 2x minus 3 whole squared here. Okay, so these powers are 4 and 2 respectively here. Okay. Let's look at the second part now. It says it's given that A takes this greatest possible value. So that means the function f, therefore, which is x minus 3 whole squared minus 1, its domain is x less than 3. So they're saying A takes this value. Okay. State the range of f and find an expression for f inverse of x. Now, what's the range of f going to be? We have done so many examples in this on finding range of quadratic functions. How do you find range of quadratic functions? You look at the graph, look at the sketch. This yellow part is what is valid. Now, in this yellow part, what's the maximum point and what's the lowest point? Lowest point on the graph is at -1. Highest point is nothing. It can go as far up as possible. So it's going up to infinity. So what's the range going to be? The range of the function is going to be anything that's greater than or equal to -1. Not equal to -1 because you see the turning point is not included here in the domain. So we don't put an equal to sign. It's just y greater than -1. That's what you write there. You say the range of f, that is going to be y greater than -1, because on the graph, you can see y could take any values greater than -1. That's the range of the function. Is that all right? Any problems with this? That was part 2. Again, that was relatively straightforward. Let's look at part B now. Part B1. Okay, now they're saying there's another function, and that's this function g. G is defined as x minus 3 whole squared for x greater than or equal to 0. Let me write that function here. G of x is equal to x minus 3 whole squared. And the domain of this function is x greater than or equal to 0. The domain of this function is x greater than or equal to 0. Okay, now given this, they want us to show that g of 2x, it can be expressed in this form, where b and c are constants to be found. Okay, let's try this. G of 2x, that's what we need to figure out. Let me write that down here. G of 2x, that's what you want to figure out. Okay. Now, let's first of all find g of x. Let's find this first of all, because what this means is in the function g of x, you have to replace x with 2x. So first of all, what we can do is we can find this function g of x. So that's g square of x, right? It's equivalent to that, g square of x. Let's find this function first of all and see what this turns out to be. How do you evaluate this? We've done multiple examples like this before. What this means is we just have to input the function g inside g. So it looks like this, g of g, okay? Now what is g? G is x minus 3 whole squared, so it becomes g of x minus 3 whole squared. So inside the function g, you need to input x minus 3 whole squared in place of x. That's what you do next now. Put this whole thing, x minus 3 whole squared, in place of x. What will that become? That will become x minus 3 whole squared, when you input this in place of x, minus 3 whole squared. This is g of x. Okay? This is what we end up getting as the function g of x. Now, what is it that they want from us? They want g of 2x. And we need to show that that somehow can be written like this. Okay, now how do you go from the form that we've got to the form that they want us to find? First of all, let's just do this, that we replace x with 2x. See what we get from that. Replace x with 2x, right? What do we get from that? G of 2x, that equals 2x minus 3 whole squared minus 3 whole squared. This is g square of 2x. Okay. All we need to do now is we need to convert it to the form that they wanted. They want us to somehow convert it to this form, 2x minus 3 whole raised to power 4, a into this, or nothing with that, plus b into 2x minus 3 whole squared plus c. That's the form that they want us to convert it to. Now, how do you go from this form to this form? You see, in the form that they have given, they don't have a whole square. They don't have any whole square there, right? What we can do is we can evaluate the square. We can think of it like this. We can say this is a minus b whole squared. This is a minus b whole squared, and that's given by a squared minus 2ab plus b squared. That's how we can simplify this. A squared, what would that be? 2x minus 3 whole squared, and then whole squared. What does that become? That becomes power 4 minus 2 into 2x minus 3 whole squared. That's a into b, which is 3, plus 3 squared. That's 9. This is what we get when we simplify this. We can simplify this further, and that gives us 2x minus 3 whole raised to power 4 minus 2 into 3. That will be 6 minus 6 into 2x minus 3 whole squared plus 9. And that is what we wanted. That's g of 2x. That's the final result that we get from this. Okay, that's what they wanted us to figure out, to show. Any problems with this? Any questions, anyone? No problems? Okay. That was B1. Let's have a look at B2 now. It says, hence expand this completely, simplifying our answer. That's 4 marks now for some reason. We need to expand this thing. How do we do that? That requires binomial. And that's why it's 4 marks now, because we need to expand this thing and then also expand the rest of them and simplify everything. What I can do is I'll just simplify this first separately. Let's see what this turns out to be. 2x minus 3 whole raised to power 4. We'll just use the binomial expansion formula on this. What's the formula? A plus b whole raised to power n, that is equal to a raised to power n plus nc1 into a raised to power n minus 1 b1 plus nc2 into a raised to power n minus 2b squared, and so on, right? That's the expansion that we will be using. Let's expand this. A raised to power n, that's 2x whole raised to power 4 plus nc1, that means 4c1 into 2x whole raised to power 3 into minus 3 plus 4c2 into 2x whole raised to power 2 into minus 3 whole squared plus 4c3 into 2x whole raised to power 1 into minus 3 whole cube plus 4c4 into 2x power 0 into minus 3 raised to power 4. Now we've got 4c4 here. We can't go any further, right? Because the next term would have the number at the bottom bigger than the number on top. So we cannot really go any further, right? We cannot go any further. So we stop at this point. Okay. What do we do next now? 2x whole raised to power 4. What does that turn out to be? That's 16x raised to power 4. Plus 4c1, that's 4 into 2x whole cube, that's 8x cube into minus 2, into minus 3, sorry. Plus 4c2, that's 6 into 4x squared into 9. And then the rest of the terms, let's simplify them as well. 4c3 is 4 into 2x into minus 27 plus 4c4 is 1, 2x power 0 is also 1, and then minus 3 raised to power 4, that will be 81. Okay, let's simplify this further. This gives us 16x raised to power 4, 12 times 8. You can see what that is. 12 times 8 is 96, right? Minus 96x cubed plus 24 times 9. What would that be? 24 times 9, that's 240 minus 24, which is 216 x squared minus 8 times 27. What would that be? 8 times 27. What's 8 times 27? 240 minus 24 again, I think, yeah. So that becomes 216x. Please confirm this. Plus, this was 1 into 1, sorry, not 0. 2x power 0 is 1, and that will be 81. Right, that's what we get when we expand 2x minus 3 whole raised to power 4. You get 216, right? Okay, so that's the expansion of this first term. Now we can simplify the whole thing. We can say, okay, now we can say g of 2x. What is that equal to? This thing, that simplifies to 16x raised to power 4 minus 96x cubed plus 216x squared minus 216x plus 81. Then you've got this. That will be minus 6 into 2x minus 3 whole squared. That's a squared minus 2ab plus b squared, right? You can just expand that directly. That will be 4x squared minus 2 into 2x into 3. That will be 12 times x plus 3 squared. That's 9. And then we've got 9 outside there as well. Simplify this further, and this gives you 16x power 4 minus 96x cubed plus 216x squared minus 216x plus 81 minus 24x squared plus 72x minus 54 plus 9. And then we simplify and get our final result after this. 16x raised to power 4 minus 96x cubed. This is 1x squared term. This is another x squared term. 216 minus 24. That will be 192. 192x squared. And then minus 216 plus 72. What's that? Minus 216 plus 72. What do you get from this? 72 minus 16, that will be 56, and then 44, I think. Minus 144? I think that's 144, right? Yeah, minus 144 times x. And then finally, we've got 90 minus 54, which is 36. That is the final result that we get from this. That's GG of 2x. That's kind of a different kind of question in which we got binomial expansion inside a function question, but that can happen as well. You know both the concepts, so you just try to apply binomial expansion to expand this thing here. Make sense? Any problems? Any questions, anyone? Is that all right? No problems? Okay, let's have a look at the next one now. Let's have a look at the next one. 52 and 56, are they questions from the functions worksheet as well? 32. Okay. 32, 52, and 56. Okay, let's try some of these now. Okay, question number 32 from the worksheet. Let's try this. Question 32. All right, functions f and g, they are defined like this. Find the points of intersection of the graphs of y equals f of x and g of x. Y equals g of x. Okay, first of all, this is another way to write functions. They don't use this in recent papers anymore, but in older papers, they sometimes use this notation for functions as well. This is actually the same thing as f of x equal to half x minus 2. This is g of x equal to 4 plus x minus half x squared. And that's what this is. It's just another way to write functions, but this is not something that they use in papers anymore. They don't do that. But you should still be familiar with this if you are attempting any older papers. Okay, so find the point of intersection of these two graphs. How do you find that? Find that for finding points of intersection of any two graphs, we just solve them simultaneously, right? So that's all that we've got to do. Solve these two functions simultaneously. One is y equal to half x minus 2, and the other is y equal to 4 plus x minus half x squared. These are two functions. We need to find the points of intersection, so we just solve them simultaneously. We've got y as the subject in both of them. What we can do is we can equate them like this: half x minus 2, that equals 4 plus x minus half x squared. Let's simplify this, take everything to the left side, and that will give me half x squared, half x minus x from the other side, that will become minus half x, and then minus 2 and minus 4 from the other side, that becomes minus 6 equals 0. I can multiply the whole thing by 2 so that I can get rid of the fractions. That will give me x squared minus x minus 12 equal to 0. Can we factorize this? we can write it as minus 4x plus 3x minus 12 equal to 0. Take x common from the first two terms, that gives you x minus 4. Take 3 common from the last two terms, that gives you x minus 4 inside as well. And you get x minus 4 times x plus 3 equal to 0. So x is equal to 4 or x is equal to negative 3. Now we wanted points of intersection. That means we want the y coordinates as well. So we can input them in any one of those two functions to get the corresponding y values now. I'll input them in the first one. Y equals half into 4 minus 2. That gives me 2 minus 2, that's 0. And when I input x equal to negative 3, I get half into negative 3 minus 2, which is minus 3 over 2 minus 2. What will that be? Minus 7 over 2, I think. Right? So what's the final answer? This is 1 point, that's 4 and 0. This is 1 point of intersection. And another point of intersection is minus 3 and minus 7 over 2. That's what we were looking for in the first part. These are the points of intersection of these two functions. Is that okay? Any problems with this? No issues? Let's move on to the next one then. Part 2. Find the set of values of x for which f of x is greater than g of x. Oh yeah, that's an interesting question. F of x is greater than g of x. How do you understand this? You see, in the first part, we have found the points of intersection of these two functions. Those are the points where these two functions are equal to each other, right? So in the first part, we have solved this equation, f of x equal to g of x. We found 2 points for that. Now you see, in the first part, this function f, this was a straight line, and this function g, that's a quadratic function. Let's try to understand how they would look graphically. This is a straight line. That's an upward sloping straight line. So it would look something like this, right? This is the straight line. Let's call this function f of x. The other function is a quadratic function. What's the shape of that quadratic function that we've got? The coefficient of x squared is negative. The coefficient of x squared is negative. So that's an n-shaped graph. So it would look like this. These two functions have 2 points of intersection. This is g of x. There are 2 points of intersection here. This is 1 point of intersection. This is another point of intersection, right? They want f of x to be greater than g of x. Okay. We need to find the set of values of x for which this is true. 1 minute. F of x is greater than g of x, right? Okay. Now the points of intersection that we got, they were negative 3 and 4. So we can say the x coordinates of these points are negative 3 and negative 4. Negative 3 and plus 4, sorry. Plus 4, yeah. So one of them is negative 3 and the other is plus 4. These are the x coordinates of the points of intersection that we found in the first part, right? Now, where is the graph of f of x greater than the graph of g of x? Where is the f of x graph above the graph of g of x? Can you see that on the graph? Where is the f of x graph above the g of x graph? It's either this part here, this region, on the left, on the extreme left, that is where the green graph is above the orange graph, or it is on the extreme right. That is where the f of x graph is above the g of x graph. So what will be the values of x that satisfy this inequality? It will be x less than negative 3 or x greater than 4. to the left of -3 or to the right of 4. This will be the solution that we get from this. Does that make sense? Any problems with this? Alternatively, you could also think of it like this. You could make an inequality and then put that inequality in your calculator. After converting it to this form, ax squared plus bx plus c greater than 0. Convert it to this form, then put that on your calculator like we have done in when we did quadratics, right? Since we have already found the points of intersection and we have showed the working for that, in the next part, we could just write down the answer directly. The question also has only 2 marks. They will just be for these inequalities that we have got at the end. Okay, you can write down the answer directly from the calculator as well in this particular question because you already showed the working for finding the points of intersection in the first part. Okay, I'll need a short break. I'll be back in a couple of minutes. There's someone outside I need to attend to. I'll be back in a couple of minutes. Okay. Okay, I'm sorry, I had to attend to something important. Okay, can you guys hear me again and also see my screen? Quick check. Yes. Okay, all right. So what did we do here in the first part? We found the points of intersection. In the second part, they wanted us to find where is the f of x graph greater than the g of x graph. So you can see that on the graph where is the f of x graph above g of x? Where is the green graph above orange graph? It's either to the left of -3 or to the right of 4. So that's our final answer, x less than -3 or greater than 4. Okay? All right, let's have a look at the next one now. This was part 2. Again, fairly tricky. The second part, we've done similar questions in trigonometry, if you remember. There were a couple of questions that we did in the trigonometry worksheet like this as well, where we had to solve some inequality using the graph. Okay, let's look at part 3 now. Now it says find an expression for fg of x. Find an expression for fg of x and deduce the range of fg. Okay, let's write that down here. the function f of x. What was that? That was half x minus 2. And the domain of this function, okay, domain of both functions is all real values. So this is one function and the other function is 4 plus x minus half x squared. 4 plus x minus half x squared, this is the other function. They want us to evaluate an expression, find an expression for fg of x, and also find the range of this. Okay, let's try this. Fg of x, that's the same thing as f of g of x. Inside the function f, we need to input the function g. Now, this is the expression that we got for g. We need to input this inside f. That gives us f of 4 plus x minus half x squared. So inside the function f, we need to input this thing in place of x. Let's do that. That gives us half into 4 plus x minus half x squared. And then we've got this negative 2 outside as it is. Let's simplify this. 4 over 2, that is 2, plus half x minus 1 over 4x squared minus 2. 2 and minus 2, they get cancelled, and we're left with half x minus 1 over 4x squared. This is fg of x. Okay, that was one thing that we had to do. We had to find an expression for fg of x. Now they want us to find the range of this function. How do you find the range of this function? It's a quadratic function. You can see it's a quadratic expression, right? How do you find range of quadratic expressions? First of all, what's the domain? What's the domain of this function? For composite functions, remember, what did we discuss? The domain of the composite function is the same as the domain of the inner function. So whatever is the inner function, the domain of the composite function is going to be the same. So in fg, g is the inner function. What's the domain for that? The domain for that is all real numbers. So the domain for this quadratic function is also all real numbers. Okay, so for finding range then, we just need to think about the graph and figure out what the turning point is. Because everything below the turning point then, we will say that's the range of the function. It's an n-shaped graph because the coefficient of x squared is negative. Let's find the turning point of this. How do you find the turning point? We know we can do this directly from the calculator. So that's what we will do. Let me rearrange this. Fg of x, this is minus 1 over 4x squared plus half x, right? One idea is that you use minus b over 2a to find the x coordinate of turning point, and then you input that value of x back in the function to find the corresponding y value. Or you could use differentiation to find the x coordinate and then input that value of x back to find the corresponding y coordinate. But we know for finding the turning point of a quadratic function, we could use our calculator directly as well. And this is one of the very few things that does not require any working in the exam. You can write it directly and you will not be penalized for this. Now, what's the we go to the equation function polynomial degree 2. X square coefficient is minus 1 over 4. Let's input that here. And then x coefficient is 1 over 2. There's no constant, so that's a 0. X coordinate of the turning point is 1. And the y coordinate of the turning point, that's 1 over 4. Okay, so that's the turning point. What's the range going to be then? Everything below this number on the y-axis, this is 1 over 4, right? So a range would be y less than or equal to 1 over 4. Y equal to, because the turning point is also part of the function, right? So that will be included in the range. We would say the range, therefore, is y less than or equal to 1 over 4. That's our final answer. Is that all right? Make sense? So we find the range of a composite function like we find the range for any other function, any normal function. We know the domain, just use the domain to find the range. Okay, so there's no special way of finding the range of a composite function. It just works like it works for any normal function. This is a quadratic function, so we looked at the turning point and the graph of the function. Now it says there's another function h, and that is defined by this. Now you see it's the same expression that we had for g as well, right? It's that same expression. Find the smallest value of k for which h has an inverse. Okay, let me do it on the side so I have the question in front of me as well. The function is h of x. That is given by 4 plus x minus half x squared. And they are saying the domain of this function is x greater than or equal to k. Okay. Smallest value of k for which it has an inverse. When does a function has an inverse? When it is 1 to 1. So we need to find the smallest value of k for which this function would be a 1 to 1 function. That's what we need to figure out. Now, what does this graph look like? It's a quadratic function. It's a quadratic function. It's an N-shaped graph. It would look something like this, right? It looks like this. Now there's some value k on the x-axis. Let's suppose this is the x-axis. There's some value k somewhere. They're saying to the right of that, the function is 1 to 1. Okay, let's suppose k was here. Then to the right of that, we have this graph. This is 1 to 1, right? But is this the smallest possible value of k for which it will be 1 to 1? No, because we can take k a bit to the left as well. We can keep going and keep going until we reach the turning point. So k can go as far back as the turning point, and still everything to the right of it will be 1 to 1. But if we go even slightly further to the left, it will not remain 1 to 1. So what's the smallest value of k going to be then? Whatever is the x coordinate of this turning point. How do you find the turning point of this function? Again, all we have to do is put this here. X square coefficient is minus 1 over 2, that's minus 0.5. X coefficient is 1, the constant term is 4, and that gives you the x coordinate of the turning point, which is 1. And that's all that we really want. X coordinate, but the y coordinate, if we wanted, that's 9 over 2 or 4.5. What's the smallest possible value of k? It's 1, right? Because on the x-axis, that's the smallest value we can have so that the function remains 1 to 1. If k was anything less than 1, it would not be a 1 to 1 function anymore. So in all such questions where they ask you for the smallest value of something or the largest value of something, and they want you to have the function as 1 to 1, you will write down the x coordinate of the turning point of that function, right? That's a standard response to such questions, but that's the logic of it as we just understood it. Okay, that was the last part. Is that all right? Should we move on to the next one now? Any questions on this? No, okay, let's have a look at the next one now. Aisha, is that from the functions worksheet? The question 52 and 56 that you posted? Or was those were those some numbers in that question that you were telling me about? 52 and 56, no. Okay, let me quickly have a look at them because Aisha is unresponsive right now. Is that what you're asking about? Question number 52 from the worksheet? Okay, 52 and 56. All right, let's have a look at these quickly, and then I want to do a couple of function transformation questions today as well. Let's start with this one. Question number 52 right now. Let's look at this. Question number 52 from the worksheet. Last two questions on functions, and then we move on to function transformations after this. Okay. The diagram shows the graph of y equals f inverse of x, where f inverse is defined by this. For x between 0 and 2. Okay. Find an expression for f of x and state the domain of f. Okay, now that's, again, not a very standard question. Generally, what they do is they give you a function and ask you to find the inverse of that function. But here they've done the opposite. They've given you the inverse function and they want you to find the original function. Now the process is going to remain the same. Because think about it. If there's a function f and there's another function f inverse, now if you find inverse of f inverse, if you find inverse of f of x, that will give you f inverse of x. But if you find inverse of f inverse of x, that will give you the function f of x. So f of x and f inverse of x, they are basically just inverse of each other. So all we have to do is find the inverse of this function. And that will give you the original function back. Okay, that's all that we need to do. Let's start with this. This is the inverse function that we're given, f inverse of x, that is equal to 1 minus 5x divided by 2x. We need to find the inverse of this function that will give us f of x. Okay, we do it the same way as before. We replace this thing with y. Y equals f inverse of x. What does that give us? That gives us y equal to 1 minus 5x divided by 2x. 2x gets multiplied on the other side, and that gives us 2xy, that equals 1 minus 5x. Take all x terms to one side. 2xy plus 5x, that equals 1. Take x common, that leaves you with 2y plus 5, that equals 1. And x equals 1 over 2y plus 5. Now, earlier, we used to replace this thing with f inverse of x. But we started with f inverse of x in this case. So we would say, let's replace this with f of x. And on the right side, replace the variable y with x. And that gives us 1 over 2x plus 5. This is the original function that we were looking for. Okay. So it's the same thing that we do when finding inverse of a function. When we find inverse of f inverse, we'll get back to the original function. Okay. All right, now it says state the domain of f. Domain of f. How do you figure that out now? Domain of f. Now we know the domain of the inverse function. Domain of the inverse function. Using that, if we can somehow find the range of the inverse function, that will be the same as the domain of f. Right? Remember the connection between domain and range of a function and its inverse? Domain of original function is the same as the range of inverse, and the range of the original function is the same as the domain of the inverse. So what we can do is, we can say the domain of f is the same as the range of f inverse. So let's find the range of this function. Okay, let's do that. F inverse of x, that is equal to 1 minus 5x divided by 2x. The domain of this function is from 0 to 2. Now, all you have to do is see what happens at 0 and see what happens at 2. Now, look at the graph. When you input 0 here, you would end up getting 0 in the denominator. If you did not have the graph given, you would use that idea that we've been using before when we used to find range of reciprocal functions by inputting some numbers. Like, for example, you would input, in this case, since 0 cannot be input directly, you would input a very small value of x, like x equal to 0.000000001 on your calculator. And from that, you would try to understand what the value of y would be in this case, right? But in this case, since we have the graph given, we can just look at the graph and see where this function is going. Close to 0, you see the function is going in the upwards direction. So it's going towards infinity, right? So close to 0, the function is going towards infinity. What about 2? 2 we can input in this function and see what that gives us. If we input x equal to 2, let's see what we get from that. F inverse of 2, that gives us 1 minus 5 into 2 divided by 2 into 2, and that will be minus 9 over 4, which is minus 9 over 4. I think that's minus 2.25. Let's just confirm that. Minus 2.25. Yeah. So minus 2.25. What that tells us is when the x value is 2, the y value of the function is negative 2.25. So what's the range of the graph going to be then? If this is negative 2.25 and vertically the graph in the upwards direction, the graph is going up to infinity, we can say the range of this graph, therefore, is going to be y greater than or equal to negative 2.25. That's the range of f inverse. Why do we put the equal to sign here? Because we have an equal to sign with 2. Since 2 is included, the corresponding y value would also be included. Okay? That's the range of f inverse. Now, if that's the range of f inverse, we were looking for the domain of f. So the domain of f should be the same. We can say the domain of f, therefore, is also greater than or equal to negative 2.25. However, since we're talking about domain now, we should have x here. So it's x greater than or equal to negative 2.25. That's the domain of this function. That's what we were looking for. And just keep it on the side here. Any problems with this? Any problems with this, anyone? No problems? Okay. Let's look at the second part now. That's just 2 marks. The function g is defined by g of x equal to this. Find an expression for f inverse of g, giving an answer in the form ax plus b, where a and b are constants to be found. Okay, now we've got another function g. Let's write that down here. G of x equals 1 over x. And the domain of this function is x greater than or equal to 1. F inverse of g is what we're looking for. Okay. F inverse of g. That means inside the function f inverse, we need to input g. So f inverse of g of x. Okay, what does that become? G of x is 1 over x. So f inverse of 1 over x, all we have to do is In the inverse function, which is this, replace x with 1 over x. What will that become? 1 minus 5x? That will be 1 minus 5 into 1 over x divided by 2x. That will become 2 over x, or 2 into 1 over x. Okay, what they want us to do now is they want us to write it in this form, ax plus b. So now it's algebra in which we need to simplify this function, ax plus b. Okay, how do we convert it to that form now? In the numerator, we can write it as 1 minus 5 over x. In the denominator, this is 2 over x, right? If we take LCM in the numerator, what does it become? It becomes x into 1, which is x minus 5 divided by x. And that's what we get if we take LCM of this part. Now, this x and this x, they get cancelled, and we are left with x minus 5 over 2. Now, is this the form that we wanted? We wanted the form ax plus b. Do we have that form yet? Can we just leave it like this? We should not. We should write it as two separate terms. So what I can do is I can write this 2 separately with this and separately with this. So it will become x over 2, or 1 over 2 times x, minus 5 over 2. That is f inverse of g of x. That's the final result that we would get from this. That's our final answer. Is that okay? Yes. All right. So these were some very good questions from the functions worksheet. Let's do one last question from this, and then we move on to function transformations. One last question on functions, and that is the one that I recommended you to attempt in the last class as well. This is question number 56 from the worksheet. Okay, question 56, let's try this. Okay, last question in functions. Let's have a look at this now. This is another type of question that you will see in past papers, that they will have a function defined in multiple parts like this. You'll have two parts in which the function would be defined. So they are saying we have this diagram that shows the function f, which is defined for x between -1 and 4. Where f of x, this whole thing is called f of x. It's defined in two parts. From -1 to 1, it follows this expression, 3x minus 2. That's a straight line form, right? So that's this form basically, 3x minus 2. They're saying this is from -1 to 1. So that means on the x-axis, if this is -1, this is +1, this line represents 3x minus 2. Okay? Then the other part, the next part, is a curve, as you can see here. That part is this reciprocal function, 4 over 5 minus x. X is going from 1 to 4. That means this point here at the end, that is 4. This green part of the curve follows this expression, 4 over 5 minus x. Now, they want us to find the range of the function first of all. How do you find the range of this function? Range, remember what that represents. On the y-axis, what's the lowest point of the graph and what's the highest point of the graph? That's all that we're looking at, right? What's the lowest point? Lowest point is this point here. This is when x is equal to -1. Now, which expression do we put that value in? It's a straight line in this part, right? So it relates to the yellow part. So what we can do is in the yellow part, we can input x equal to -1. What's the value of y that we get from this? 3 into -1 minus 2. That will be -3 minus 2, which is -5. So that means this point here is -5. Okay. Similarly, look at the other extreme point, this point here. The x value here is 4, but this value will be input in the green function, which is the curve, right? Which is the curve. That's when x is equal to 4. So what's the curved part now? 4 over 5 minus x. Let's input the value of x here. That will give us 4 over 5 minus 4, which is 4. So the y value here is 4. On the vertical axis, this point is going to be 4. So what's the range of this function then? The range of the function is from -5 to +4, right? -5 to +4. This point is included. This is also included. So we would include -5 and 4 as well in the range. We can say the range of the function therefore is from -5 to 4. We write it as a single inequality. Smaller number on the left side, bigger number on the right side, and less than signs like this. Okay, that's the first part. Now it says in the second part, copy the diagram and on your copy, sketch the graph of f inverse of x. Remember the relation between f of x and f inverse of x? What's the relation between the graphs of f of x and f inverse of x? They're reflections of each other, right? Zara, I've not seen a question like this from 2020 onward. However, it's still part of your syllabus, so they can test it. It may just be a coincidence that it's not been coming in the more recent papers from 2020 onward, but they can test it. Okay, there's nothing uh, here that has been excluded from the syllabus as such. All of this is still part of your syllabus, so this can definitely come in your exam as well. Okay, all right. So f inverse is a reflection of f of x in the line y equals x, right? So what we can do is we can draw the line y equals x here. Y equals x line is going to pass through 0. And this point is 4, 4. So it must also pass through this point, right? Because at this point as well, x is equal to 4 and y is equal to 4. So it satisfies that line. We can draw a line like this, y equals x, such that it passes through that point 4, 4, and also 0. So it will look something like this. That's the line y equals x. Okay, this is the line y equals x. Now, f and f inverse, they are a reflection of each other in this line. You just have to reflect the graph. Now, the point 4, 4, when reflected, it will remain there. This point 1, its y coordinate is also 1. This is also going to remain here. So what's the graph of f inverse going to look like in this part? Just reflect this green part of the graph, and it would look something like this. Okay, this is the curved part of the inverse function. And then what's this point? This point had an x coordinate of -1, a y coordinate of -5. Where will this point go in the inverse function, in the inverse graph? You switch the coordinates, right? -1, -5 becomes -5, -1. So you would have -5 somewhere here and maybe -1 here. So that point may be somewhere around here. So that means the straight line is going to look like this. This is the f inverse graph. That's what you would draw on the graph. Okay, so that this point here is -5 and -1. That the red graph that you see, that's the inverse function. Okay. That was part B. Now, let's look at part 3. It says, obtain expressions to define the function f inverse, giving also the set of values of x for which each expression is valid. Okay, now we need to find the inverse function. This is the original function. We need to find the inverse of this. And we need to describe that in a similar format to it. Okay? Now, how do we do that? There's a straight line, there's a curve. So what we can do is we can find the inverse of each of them separately. So we have two parts of this function. One part is f of x equal to 3x minus 2, and x is between -1 and 1. And the other part is f of x equal to 4 over 5 minus x. And that part is valid from 1 to 4. Let's find the inverse of both of these parts separately. For the first one, let's say y equals f of x, and that gives us y equal to 3x minus 2. Make x the subject, and that will become 3x equal to y plus 2, x equals y plus 2 divided by 3. Now, what's the inverse going to be? F inverse of x, that is equal to x plus 2 over 3. And then similarly, you can find the inverse of the second part of the graph. Let y equals f of x, and that gives you y equal to 4 over 5 minus x. Multiply this thing on the other side, and that gives you 5y minus xy, that equals 4. Xy equals 5y minus 4. I can divide y on the other side, and that will give me x equal to 5y minus 4 over y. So f inverse of x, that becomes 5x minus 4 over x for this part. Okay. Now, we need to describe f inverse in a similar format, that what's the corresponding values of x for which this function is valid. Now, they made us sketch the graph in the previous part. In the previous part, we have already sketched the graph. Can we just see from the graph for what values of x these two parts are valid? This straight line, first of all, is going from -5 to 1, right? And then the curved part of the inverse function, that's going from 1 to 4. So that's what we can write there then. We can say the straight line is valid from -5 to 1. This part of the graph, right? It's valid from -5 to 1. So for this, the domain is -5 to 1. Now, do we include both of them? Yes, because the corresponding x values are also included. The corresponding values for the original function are also included. We put equal to sign with both of these as well. And for the second part, we are going from 1 to 4. Okay, let's write that here. 1 to 4. Now, for the second part, 1 was not included. So the corresponding value here, 1, will also not be included. We will not put an equal to sign with that. With 4, however, we do put an equal to sign. If we wanted to write it in a similar format, like they did here, we could say f inverse of x, that is equal to two parts. One is x plus 2 over 3, which is valid when x is between -5 and 1. And the second part, that is 5x minus 4 over x, and that is valid when x is between 1 and 4. That's what the inverse function would look like. That's the last part of this question. Is this okay? Any problems with this? Any questions, anyone? One, I'm not sure if I get that reference, but okay. F inverse of x, that's the result that we get. Okay. Okay, let's have a look at a couple of questions on function transformations now. Let's move on. Let's move on to function transformations. We're done with all of these concepts as well. Let's have a look at some of the more difficult questions on function transformations today as well. Okay, function transformations worksheet now. Function transformations. Let me connect my charger. Other device, just give me a second. In fact, I'll just show you the question and then I'll connect the charger. So which questions do you want to do from this now? 11 and 12. Okay, so 11 and 12. These are two questions that we will look at. Am I looking at the wrong worksheet? Okay, this is the marking scheme. I'm sorry. Function transformations worksheet. Okay, 11 and 12. Okay, these are both good questions. They involve trigonometry though. Okay, 11, 12, and the rest of them you were able to figure out? No other problems? 6 was also a good one. If you haven't attempted that, make sure to do that. But let's start from 11 and 12 then. Let's have a look at these two questions. Okay, what I'll do is I'll connect my charger quickly to the other device. Just give me 1 second. Okay, let's start with 11 and 12 now. Okay, 12 looks relatively easier. We'll do this first and then do 11 after that in this order. And then if we have time, we might just do 6 as well. Let's start with 12 and then we'll do 11 after this, okay? In increasing order of difficulty. Let's start with 12. Okay, take a minute, read the question statement, and then we will discuss it. The diagram shows the graph of y equals f of x, and f of x is given as 3 over 2 cos 2x plus 1 over 2, and x is going from 0 to pi. We need to state the range of f. Okay, that first part is relatively straightforward. How do we do this? We can see the graph is completing one cycle, right? We can see it from the graph as well. All we have to do is, since it's a cos function, in place of cos 2x, input -1 and input 1 and see what values you get from that. Make sure your calculator is in radian mode, although in this case, in the first part at least, it doesn't matter, but they have radians here. So it's just a good idea still to convert it to the correct unit in case you need that in a later part. 3 over 2 into -1. So you input cos equal to -1 first of all. That's one extreme value of cos, right? That gives you -1. That means the lowest point here on the graph is -1. What about the highest point? Input 1 there. The highest point on the graph is going to be 2. And that's it. That's what you're looking for. There are a number of different other ways of doing this as well. We could use the table function on our calculator, as we've seen before. In this particular question, just looking at the graph, you can see the maximum value is when x is equal to 0, and the minimum value is exactly in the middle of pi. That means 0 and pi. So that's pi over 2. So you can input x equal to 0 and x equal to pi over 2 as well. That could also work. Or the standard method that we had for sine and cos functions. If the cycle is completing, we just input -1 and 1 and see what corresponding values we get from that. So the range of this function, what is that going to be? It's going to be between -1 and +2. Okay, you can use the table function method as well. I'll just show that to you quickly. Just as a reminder, just input this function here, 3 over 2 into cos of 2x plus 1 over 2 input this function in the table, start at 0, end at pi. That's what we're given there. Divide the interval into 8 parts, right? Divide by 8, that will become 9 parts actually. But divide the interval by 8, so that's pi divided by 8. That's your step. These are the y values that you get. Now just look at the table. What's the highest value in the table? That's going to be 2. Then keep going down and see what's the lowest value. -1 is the lowest value. It's not getting any smaller than that. So in your table, amongst the y values, the biggest value is 2 and the smallest value is -1. That's what you can write. You can say the range is from -1 to 2. Okay, so the first part was fairly straightforward. We could do it like this. Okay, let's look at part B now. Okay, it says a function g is such that g of x is equal to f of x plus k, where k is a positive constant. The x-axis is a tangent to the curve y equals g of x. Okay. State the value of k and hence describe fully the transformation that maps the curve f of x to g of x. Okay, so what they're doing is they're saying there's another function g, and it's such that g of x is equal to f of x plus k. What kind of transformation is that? F of x is as it is. Outside f of x, they are adding some number. They're adding k. That's a vertical translation, right? Outside, you're adding something. So your graph is going to move up by k units. Now they're saying it moves up in such a way that x-axis is a tangent to the curve. It's moving up because they have told us that k is a positive constant, right? So it can't be negative. It's not moving down. It is moving up. Now, how much can you move this function in the upwards direction such that the x-axis becomes a tangent to the curve? Currently, this value is at y equal to -1. So if you take it 1 unit up, the graph is going to look like this. It will become a tangent at this point, right? Roughly like this. It's not a very good sketch, but you get the point. It's going to look something like this. Okay. So if you move it 1 unit in the upward direction, it'll become a tangent to the x-axis. So what's the value of k going to be then? We just move it 1 unit up. So we say the value for k therefore should be equal to 1. What's the transformation that maps f of x to g of x? We have talked about that already. It's a translation. For translation, we always have to write down a vector, otherwise that's not acceptable. What's the vector going to be? It's 0, 1. 0 on the horizontal axis, 1 unit up on the vertical axis. That's the result that we get. Okay, that's part B. That was again not very difficult. That's it that we had to do in the second part. The third part says state the equation of the curve, which is the reflection of y equals f of x in the x-axis. Reflection of f of x in x-axis. What kind of reflection is that? Is that something that we call a vertical reflection or a horizontal reflection? Reflection in x-axis. This is the x-axis. The point that's above, that will go down. The point that's down that will go up. We call this a vertical reflection. And in vertical reflection, whatever operation is applied outside the function, outside f of x. So what we do is we multiply the whole function by negative outside minus f of x. That's what we're looking at. That's the equation of the curve y equals minus f of x. Now let's Simplify this. What's f of x? F of x was this, 3 over 2. Remember, the negative is going to come with the whole thing. Okay, so it'll be outside the bracket like this. Minus 3 over 2 into cos of 2x plus 1 over 2. You can simplify this, and that gives you minus 3 over 2 into cos 2x minus 1 over 2. And that's it. That's the function that we were looking for. So this is not very complicated, actually. This one. Is this all right? Any problems? Just give me a second. Okay, let's look at the next part now. Next question now. That's question number 11. Okay. This, just by looking at it, looks pretty complicated. This one, question number 11, let's try this. It might be the last one that we're able to do today. Question number 11 from the worksheet. Let's try this. Okay, let's try this. It says functions f and g are such that f of x is equal to 2 minus 3 sine 2x and g of x is equal to minus 2 f of x. State the ranges of f and g. State the ranges of f and g. Okay, how do we do this? Let's start with sine, first of all, the sine function. How do you find the range of f of x? How do you find the range of f of x? Is a cycle completing for sine from 0 to pi? Is a cycle completing for sine? It is completing because it's 2x, right? 2x means the period of the graph becomes half. So it was 2 pi originally, now it becomes pi. So it is completing one full cycle in this interval. That means we can just input minus 1 in this and 1 in this. See what you get at minus 1, see what you get at 1, and that will give you the range. Alternatively, if you don't want to think that much, just use the table function, and that will be fairly straightforward. You won't even need any working for that. Just put this function here. In fact, what I can do is it'll actually be better to use the table function because we also need that for the next part. Then they want us to sketch the diagram. And remember, for sketching these graphs, we always just use the table function on the calculator. So we'll use the table function. We will use the table function to find the ranges first of all, and then use the same table function to sketch the graph as well. Okay, let's try that. 2 minus 3 sine of 2x. Let's input this function first of all. That's f of x. What I'll do is I'll just input g of x as well at the same time. what's g of x going to be? It's minus 2 times f of x, right? So minus 2 into 2 minus 3 sine of 2x. Let's just input that here as well. So we can do everything at the same time. Minus 2 into 2 minus 3 sine of 2x. Right? Where do we start? Both the functions have the same domain, right? So we start at 0, we end at pi. And then we used to say we would divide the interval by 8. So pi by 8. That's the step that we take. That's a safe step to take in most cases. Now just look at the table and see what's the maximum value of y for each of the two functions, for f of x and g of x. What's the maximum y value? What's the minimum y value? And that will give you the range of the function, ranges of the function. Let's start with f of x first of all. In the table, what's the greatest value of f? Okay, so currently I can see 2 and minus 1 being the lowest currently. Okay, 2, 4. Okay, we're going to 4 as well. 5. Okay, it's getting to 5. And okay, 5 is the biggest value and minus 1 is the smallest value, right? So it's not going below minus 1 and it's not going above 5. So what's the range of f going to be then? Range of f is from -1 to 5. What about g? You can do the same thing for g as well. In the table, what's the smallest value that you can see for g? Okay, so we've got -4. Okay, 2, -4, 2. Okay, it's going more negative. That's -10. And okay, so -10 is the least value and 2 is the greatest value. You can go through it again just to confirm. -10 and 2. We don't have any value outside that interval, right? -10 and +2. So that's what we write here. We say the range for g, therefore, is going to be from -10 to 2. We can write these ranges in terms of y as well, and that's okay. In that case, we will have to specify which one corresponds to f, which one corresponds to g. So the first one is for f, this one is for g. We could also write it in terms of y. We could say for the first one is from -1 to 5, and the second one is from -10 to 2. That will also be fine as long as you make it clear that the first one is f and the second one is g. All right, so that's the range of the function, ranges of the two functions. Now it says sketch on the diagram the graph of y equals g of x. They have already shown us the graph of f of x here. Okay, now how do we do that? One way to do this could be using transformations. What transformation is applied to f of x? It's a stretch by a factor of -2. A vertical stretch by a factor -2. Or you could also say it's a stretch by a factor of 2, vertical stretch by a factor of 2, and a reflection in x-axis. Both would work. And then you could sketch the graph using that. Alternatively, we already have the table function. We know the values of y at different x values. We could also use that from there. So whichever of the two you prefer, let's mark some values on the x-axis. This is 0, this is pi, right? So exactly in the middle, there will be pi over 2 somewhere. It will be somewhere around here. Pi over 2. Okay. Now let's just mark some points. What's this value here? Remember the original graph is f of x. It will help to mark the corresponding values of y on this axis. So f of x is starting from 2, right? So this point is 2. And then it becomes -1 at some point. This is -1. Then it becomes 2 again at this point. And then it goes to 5. So this point, the maximum point, this is 5. And then at the end, it comes back again to 2, right? That's how the graph is moving. Now, when f of x is 2, what's the corresponding g value? It just gets multiplied by -2, right? Because that's what you're multiplying outside, -2. So 2 into -2, that's -4. You can see that in the table as well. So this point will go to -4. That will be somewhere around here, let's say. This is -4. So the g of x graph is going to start from here. And then the next point, the point at -1, where will that go? You can see in the table as well, it's going to 2, or you just multiply this by -2, that gives you 2. So the next point is going to be here. This is the next point for g of x function. Okay, what happens here then? It's again 2. So g is going to be 2 into -2, which is -4. That's this point on the table as well. This is the next point that you get. Okay, then the next one is 5. 5 into -2 is -10. And the table as well, you can see 5 corresponds to -10. So this will go to -10 somewhere down there. Let's say this is -10. So we'll have a point here, right? Roughly. And then finally, the last point here, this is 2 into -4, 2 into -2, that is again -4. You'll have this point here at the end again. You just draw a graph through these points. It's still a sine function, so the shape is going to be of sine. It's going to look like this. You'll have this graph here, and this here, this, and this. This is g of x graph. I showed you how to do it using both methods, using the table function and using transformations. You could use any of them. Okay, and you'll get the same result from any of them. Is this okay? Any problems? Okay, now it says there's another function h. There's another function h, and that is such that h of x is equal to g of x plus pi. Okay. Part C. We had one function f of x first of all. Then g of x was -2 times f of x. And then h of x is g of x plus pi. They're saying describe fully a sequence of transformations that maps the curve f of x to h of x. So what do we do to f of x to get h of x eventually? What transformations are we going to apply on that? That's the question. So starting from f of x, how do we go to -2f of x first of all? What transformation is applied? It's a vertical stretch, scale factor -2. Or you could describe it into two parts, as well. You could say it's a reflection in x-axis and a vertical stretch scale factor 2. Okay? From f of x to g of x, that's your first transformation. Let's start from that. We can say it's a vertical stretch. It's a vertical stretch with scale factor -2. That's one transformation that's happening. And then the other, what are you doing to the function g now? Inside the function, you're doing plus pi. Inside the function, you're doing plus pi. What does that mean? It's a horizontal translation. Plus means you are going left. Plus means you're going left. In horizontal transformation, remember, when you do plus something, that means left. So we can say it's a translation first of all. It's horizontal, so we will have some x component and the y component will be 0. What will be the x component? Plus pi means you're going pi units to the left. It will be negative pi and 0. That's the translation that we get from this. And that's our final result. Is that okay? Any issues with this? These are the two transformations that map f of x to h of x. Okay, I hope that was helpful. I don't know why I remember a couple of other questions as well that I think you should definitely attempt if you haven't done them. I think that they're probably not in this worksheet. What I'll do is I will show them to you. So this is one very good question, question number 6. And okay, so there are a couple of other questions which are not in this worksheet, and I would recommend that you attempt those as well. Let me quickly find them so I can share them with you. Okay, this is already there. Okay, this is a good one. It's from March 2021. I don't know why it's not in that worksheet. I'll copy this there. This one is okay. This we've already done as well. This as well. Yeah. So these two questions, please make sure that you attend these as well if you haven't already. These are from March papers. For some reason, they're not in that worksheet. I've added them to the notes. Okay, so what I'm doing is I'm making another copy of this in the notes. One of them is with the solution, and the other, from the other, what I'll do is I'll get rid of the solution. So you can attempt it yourself first. And then if you want, you can have a look at the solution after that. Okay, is it the same question? Yeah. Okay, these are two other good questions that are not in that worksheet, and I would recommend that you attempt these as well. You can take a snapshot right now if you want, or I've added them to the notes as well, to the OneNote notebook. You can have a look at that as well. You need to try this question that you have on your screen right now. Okay, and then this one as well. You can take a picture of this as well. Okay, make sure to do this. I've added their solutions. I've added their solutions to the notebook as well. All right. Question number 14 is not that. 14 is different. March 2020. This one is 2022 and 2021. These are different questions. Okay, they're not in the worksheet. So please make sure to attempt these as well. 13, yes. So 13 was, no, it's not the same. It's different. This one is different. Okay, please make sure to attempt these questions along with the rest of the worksheet. If you have any problems, we could discuss them in the next class as well. But now we're left with only two topics, which are the relatively easier ones, APGP and circular measure. In the next week, we will be starting circular measure. We'll do that first. That's a shorter one. And then APGP is also not that big. So by the week after the next one, we should be done with our syllabus, inshallah. Okay, I'll see you again in the next week. Allah Hafiz.